Looking at trigonometry, this may be a bit of review for you from geometry. Probably touched on this a little bit, so we're going to dive back into that and expand on it a little bit. So first of all, let's look at the word trigonometry. So the first part is tri, that means three. Think of like tricycle. Then we have gon, that means shape. Think of like pentagons or hexagons or octagons. And then the last part, it has the same root as like meter or metric, so we're measuring right triangles. Well, we can measure triangles in three-sided shapes in general with this, but we're going to stick pretty much exclusively to right triangles. So when we do this with right triangles, we're always doing it in reference to some angle, which we'll call theta. That symbol is the Greek symbol for theta. So if we're looking at the sine of an angle, so say sine of theta, that's the ratio of the opposite side to the hypotenuse. So when we're talking about opposite, what we mean is the leg. The legs make the right triangle or the right angle. So the leg that is opposite the triangle from the angle. So we go across the triangle, that's the opposite side. The hypotenuse is always opposite the right angle. So if we have opposite over hypotenuse, that's going to be the sine ratio. And those are the two sides we use. For the cosine, it's adjacent over hypotenuse. Adjacent means next to, so it's the leg that's next to the angle or the one that forms the angle with the hypotenuse. And then the tangent is the opposite side divided by the adjacent side. You may recall SOHCAHTOA. I prefer it written like this, with showing that the opposite is over the hypotenuse, adjacent is over the hypotenuse, and tangent is over adjacent. But if you like it written out just plainly, that's fine too. But that can help you remember which one uses opposite, adjacent, and hypotenuse. Recall the Pythagorean theorem as well. Something about the Pythagorean theorem, this is really talking about areas of squares built on the legs and the hypotenuse of a right triangle. So on the right side here, you can see this right triangle here. The area of the square built off of leg A is a squared. In this case, it's 9. 3 squared is 9. The green square is a 4 by 4, making it 16. If you add 9 and 16 together, you get 25, which is the area of the red square. So this is really a statement about the areas of the squares built off of the sides of a right triangle. But we can use it just algebraically as a squared plus b squared equals c squared. A couple things about the angles of triangles you're going to want to remember. First of all is that all three angles, if you add them up, for any triangle you ever see will be 180, as long as that triangle is on a flat surface. Also, the two acute angles, so if you have a right triangle, the two acute angles are going to be complementary, meaning they add up to 90 degrees. So if one of the angles is 90, that just leaves 90 for the other two, since they all three have to be 180. One last thing you're going to want to remember, and that is that if you're trying to find side lengths of a triangle, you need to use regular, sine, cosine, or tangent. If you're trying to find an angle in a triangle, then you need to use one of the inverses, sine inverse, cosine inverse, or tangent inverse. And those can all be found on your calculator, which we will use for example 1. So in example 1, we are given one angle and one hypotenuse. Well, the only hypotenuse, I guess. So first, let's find the other angle. I'll call that angle x, and I'll call this y and this z. So let's start by finding x. Well, all three angles have to add up to 180. One of them is 90, so that just leaves 90 for the other two. One of those is 24, so that just leaves 66 for that angle. So x is 66. Let's now find z. So I could use either 24 or 66, it doesn't matter. I'm going to use 24 as my angle. So z is opposite 24, which means I'm going to need to use, I could use either sine or tangent, but if I want to try to use tangent, then I would need to know the adjacent side, which I don't. So let's use sine. So the sine of 24 is equal to the opposite leg, which is z, over the hypotenuse, which is 8. Multiply both sides by 8 to solve this. And we get z equals 8 times the sine of 24, which is approximately 3.3. Now grab your calculators and put 8 times the sine of 24 into your calculator. Make sure that you get 3.3 approximately. because if you don't get that, then that means your calculator is in the wrong mode, which means you're going to get all the wrong answers, so you want to make sure to bring your calculator to me. If you don't know how to change that, bring it to me. I can show you how to change that. And for y, we could use sine, cosine, or tangent depending on what angle we use. I'm going to stick with the 24-degree angle, and I'll say the cosine. So the cosine of 24, that's equal to the adjacent over hypotenuse. Adjacent to 24 is y, and the hypotenuse is 8. Multiply both sides by 8 to solve, and we get y is equal to 8 times the cosine of 24, which is approximately 7.3. So we have solved this triangle now. We found all of the sides and all of the angles. Let's go to example 2. You'll notice in example 2 we're given 2 side lengths this time and no angles. So since we have 2 of the 3 side lengths and it's a right triangle, we could just use the Pythagorean theorem to find the third one. Or if you remember what a Pythagorean triple is, you may recognize this as a Pythagorean triple. So what that means is that this will come out very nicely. And actually I just wrote the answer there as I was thinking about it. So let's call that C. So 9 plus 16 is 25. That's equal to C squared. Then we just take the square root of both sides, and we get C equals 5. So this is a Pythagorean triple, meaning that if we plug 3, 4, and 5 into the Pythagorean theorem, we get this nice answer that works out very nicely. No decimals, nothing like that. All right, we found the third side length, so let's just find the 2 missing angles. I'll call them x and y. So let's start with x. If I want to do x, I could find it using the sine inverse. I got to use inverse because I'm finding an angle. Could do the sine inverse of 4 divided by 5. That's opposite divided by hypotenuse. I could do the cosine inverse of 3 divided by 5. That would be adjacent over hypotenuse. Or I could do the tangent inverse of 4 divided by 3. That would be opposite over adjacent. I'm going to do sine inverse though. So the sine inverse of opposite is 4 divided by hypotenuse is 5. Plug that into the calculator. And to do that on your calculator, you need to hit second sine, and that will bring it up for you. Then just hit 4 divided by 5, enter, and you get approximately 53.1. To find y, we could do the sine inverse of 3 divided by 5. We could do the cosine inverse of 4 divided by 5. Or we could do what I'm going to do is the tangent inverse of, that would be the opposite is 3, and adjacent is 4. Plug that into the calculator, and you get approximately 36.9 if you round to the nearest tenth. Now to check this, we can add 53.1 and 36.9 together, and you'll see that you do get 90, which makes sense because these 2 angles have to add up to 90 degrees since it's a right triangle, and so one of the angles is 90.